students, welcome to the Rashmi's classes. Today we'll discuss on most asked interview question in 5G-NR. Question -1. What is 5G-NR? New radio. Answer -1 is to 5G stands for 5th generation and NR stands for new radio. This technology is evolution to LTE Advance and LTE Advance Pro. The standard is published with 3GPP release 15 and above. Question -2. What is the difference between 5G-NR and 4G LTE? Answer -2 is to 4G LTE and LTE Advance follows 3GPP Rail 0.8 and Rail 0.12 respectively. 5G follows Rail 15 and above. 4G operates below 6 GHz whereas 5G-NR operates at various frequency bands with sub-1 GHz, 1 to 6 GHz, above 6 GHz in wave bands, 28 GHz, 40 GHz etc. 5G supports higher data rate than 4G. 5G delivers about 10 gigabits per second whereas LTE Pro delivers 3 gigabits per second. 5G offers latency of less than 1 millisecond whereas LTE Advi Pro delivers less than 2 milliseconds. Question -3. Explain 5G-NR network architecture, its elements and its network interfaces. Answer -3. There are 3 elements in 5G-NR architecture viz. UE, user equipment, RAN and core network. NG RAN houses GNB radio, IE base station, control unit and data unit. Here AMF stands for access and mobility management function and UPF stands for user plane function. Question -4. Explain difference between TDD and FDD in 5G-NR. Answer -4. In FDD mode, both uplink and downlink can transmit at the same time at different spectrum frequencies. In TDD mode, both uplink and downlink use the same spectrum frequencies but at different times. 5G FDD is used where both uplink and downlink data rates are symmetrical. Interference is less in FDD topology whereas it is more in TDD topology. 5G TDD is used where both uplink and downlink data rates are asymmetrical. Question -5. Define use cases of 5G-NR with EMBB, MMTC and URLLC. Answer -5. This 5G FAQ judge knowledge of 5G cores such as EMBB, MMTC and URLLC. EMBB refers to enhanced mobile broadband which is used to support peak data rate of 10 to 20 gigabits per second. MMTC refers to machine-type communications which is used to support low data rates, 1 to 100 kilobits per second in M2M applications. URLLC refers to ultra-reliability and low-latency communications which is used for ultra-responsive connections with latency of less than 1 millisecond. URLLC offers low to medium data rates. Question -6. What are the different types of handover in 5G-NR? Explain each in brief. Answer -6. There are 2 types of 5G-NR handovers viz. Network controlled and UE controlled. The other types mentioned in the standard are 5G-NR inter-GNB handover and 5G-NR intra-RAN handover, C-plane handling. Question -7. What are the functions of MIB and SIB in 5G? Answer -7 is to 5G Master Information Block. MIB includes system information transmitted on XBCH transport channel and XBCCH logical channel. The IE information element X system information block contains RRC, radio resource configuration, information which is common for all UEs. It is transmitted on XBCCH logical channel and XBCH transport channel. Question -8. Explain 5G-NR deployment scenarios or modes with NSA, non-standalone, SA, standalone, homogeneous mode and heterogeneous mode. Answer -8. In SA mode, UE works by 5G RAT alone and LTE RAT is not needed. 5G cell is used for both C-plane, control plane, and U-plane, user plane, to take care of both signaling and information transfer. In NSA mode, connection to both LTE cell and 5G cell are mandatory. In this non-standalone mode, LTE is used for control, C-plane, functions e.g. call origination, call termination, location registration etc. whereas 5G-NR will focus on U-plane alone. Question -9. What is the range and speed in 5G-NR technology? Answer -9. 5G speeds of about 20 gigabits per second in the downlink and 10 gigabits per second in the uplink are benchmarked by 5G operators once the 5G network matures. Recently, many operators have achieved 5G throughput, a 5G speed in the range of about 5 gigabits per second. 5G range is lesser than supported by 4G LTE or 3G networks. It is more of equivalent to Wi-Fi range than cellular range. Question -10. What are the functions of RRC layer in 5G-NR? Explain RRC states with state diagram. Answer -10. Following are the functions of RRC layer. Following are the functions performed by RRC layer in 5G-NR protocol stack. Broadcast SI, system information, messages to AS, access stratum, and NAS, non-access stratum. Handles paging initiated by 5GC, 5G core network, or NG-RAN, radio access network. Establishment, maintenance and release of RRC connection between 5G-NR UE and NG-RAN. This includes addition, modification and release of CA, carrier aggregation, and dual connectivity in NR or between A ultra and NR. Security-related functions including key management. Establishment, configuration, maintenance and release of SRBs, signaling radio bearers, and DRBs, data radio bearers. Mobility functions such as handover, context transfer, UE cell selection, reselection, control of cell selection, reselection, inter-rat mobility etc. Cause management. UE measurement reporting, control of reporting. Detection of radio link failure and recovery from radio link failure. NAS message transfer from NAS to UE. Question -11. Which are the KPIs used in 5G-NR? Answer -11 is to 5G KPIs are categorized into EMBB, URLLC and MMTC. The common KPIs are peak data rate, peak spectral efficiency, latency, traffic capacity, connection density, energy efficiency, reliability and so on. Question 12. What role could or should small cells play in 5G networks? Answer. Small cells may play a big role in 5G. NGMN 5G white paper assumes the use of small cells in 5G, notes RCR wireless, but those cells will need better security. Concepts like cell densification are poised to shake up mobile network design, and one way things could go would be architecture that natively supports small cells, unlike LTE. Question 13. Will the Internet of Things, IoT, generate video traffic? Answer. It depends on what you classify as a thing. If it includes HD surveillance camera, for example, that runs on a cellular network, then yes, and lots of it. Smaller things, such as temperature sensors, will generate far less traffic, but there may be billions of them deployed, so it adds up quickly. For the most part, the challenge of IoT will likely be about the number of individual services, not capacity. Question 14. How will 5G latency be lower if processing is being done in the cloud? Answer. Latency in the case of 5G refers to over-the-air latency between the user device and the radio access network radio. To reduce overall latency, service providers will need to put data much closer to end users, which is why some MENS are considering leasing space at their cell sites to host data and applications for content providers, particularly in large urban centers. Ultimately, the placement of data and processing will be determined by the supported 5G application. The Mobile Edge Computing (MEC) initiative will play a major role in addressing this important challenge. Question 15. Will small cells be required to implement 5G? Answer. Definitely. This is mainly because 5G will use higher frequencies, which don't travel as far and don't travel as well through obstacles, such as buildings so prevalent in concrete jungles, cities. This means mobile network operators must install 5G radios, and a lot of them, closer to end users. Small cells won't be required day one, as they can be installed over time. But there's no getting around the fact that rolling out 5G to large geographic areas will require a tremendous number of new small cells. Question 16. What is the use of MIB and SIB in 5G? Answer. 5G Master Information Block, MIB, includes system information transmitted on XBCH transport channel and XBCCH logical channel. The IE, information element, X system information block contains RRC, radio resource configuration, information which is common for all UEs. It is transmitted on XBCCH logical channel and XBCH transport channel.